They did do some avionics changes, and this is a significant change here. And this was necessitated in order to, or this was embodied in order to necessitate turning my NDs into now multifunction displays, because I've now managed to get 8 pictures displayed from 4 screens. So they've called it Boeing have called it the Max Display System, which is a fully fledged self-contained system specifically for the Max, and it shows all the data on 4 liquid crystal displays, 4 LCD screens, round about the size of an A4 sheet size of paper. So they're a lot bigger than the old square display units. The old six display units now. We only have 4, but we have possibility of 8 pictures on 4 screens. So in order to necessitate all these pictures, it has 2 display processing computers, DPCs they're called, and I call them the do everything box. The do everything box because what they do is they collect all the data from the aircraft, and they are responsible for putting up the displays that the pilots see. We'll elaborate more on that in a minute. Apart from the 2 DPCs, the display processing computers, we've got 4 display units, 2 EFIS control panels, which are exactly the same locations as the NG, left and right or outboard of the autopilot P7. Okay, a multifunction panel, 2 lighting control modules, an instrument switching module up on P5, and the MDS, the Max Display System, normally shows the primary flight data on the outboard DUs. So it's pretty standard on these sort of aircraft now that the primary flight display, or if you want to call it the short-term navigation, or if you want to call it the up, down, left, right, is usually the outboard screen, which is in direct view of the flying pilot, because that's what it is. It's an up, down, left, right, and he needs to have it within his field of vision. So the primary flight display is usually the outboard display. However, if, for example, that display was US, it is switchable to be used on the inboard. So the pilot flying would just maybe have to move his head a bit. He wanted direct sight. Yeah, but it's possible. What we're trying to say here is we have all these possibilities, or these DPCs enable to put any picture on any screen that we wish to have displayed. Okay. We also have, apart from the outboard display units, which is the up, down, left, right, we have the inboard display units, which show the navigation data. Okay, or the NAV display, and defaulted on the inboard side of the left-hand display unit is the EI display, the engine and instrument display. Okay, which is defaulted here on this picture on the left inboard display unit, but can be switched to the inboard side of the right inboard display unit. Okay, so as we said, all switchable, all possibilities available to do whatever we like. So again, the DPCs, the do everything boxes, they receive all the inputs from all the avionics and all the airframe systems, and they are responsible for transposing all that data, whether it be digital, analog, 429, 629, whatever it is, into video signals that can, through graphics cards, that can then be displayed on these 4 displays. All right. So in detail, primary flight display, we said PFD is the up, down, left, right, short-term navigation, the immediate navigation. So it presents info on the outboard displays that normally show like this in a PFD and a mini-map display with the auxiliary outboard display. The auxiliary outboard display are these two displays here on the outboard side of the navigation of the PFD, this one and this one. And they include additional data like they got the clock, they got the flight number, they've got displayed all the information data like the cell call, the aircraft registration, and the date, for example, and things like that the pilot needs to have at his fingertips, his or her fingertips. There's even a Cat 3 status, auto lounge status there, so that they can be available at the cruise whenever they need to refer to that data. Inboard is the primary flight display with, as usual, the airspeed indication, the attitude, up, down, left, right, the barometric altitude, the vertical speed, the radio altitude, flight mode annunciations, what state the autopilot is in, and the lateral and vertical deviations. The data on the mini-map, here and here, we could have a heading, so the top half of a compass rose, the selected heading, the active flight plan, the ground speed, and the true airspeed. So the pilot doesn't even have to move his eyes anymore, left or right, on board and look on the navigation display, because he's got it all on one display unit. Okay, so it's a bit of an ergonomic sort of improvement for the crew resource management and pilots to have everything on one screen, albeit cut off. But to be honest with you, that display there, that HSI, why on earth for 50 odd years we had an HSI with 4 compass rose showing everything behind us? What do I care what's behind me? I care what's in front of me. So this picture is a much more accurate indication and depiction of what I actually need when I'm flying at 600 miles an hour, rather than having a 4 rows with everything that's happened behind me. I don't care what happened behind me. So this is probably the much better thing, and I'm surprised that it took so long for us to embody this sort of stuff. The navigation display. Well, I'm just going to show one. There's various options. You can have a compass rose, an approach mode, ILS mode, a VOR mode, but we're just for this purposes of this exercise, we're going to show the approach picture that could be selected on the EFIS control panel, left and right of the P7. So the approach display can show in either an expanded view and a center view. The expanded full screen mode shows 140 degrees of the compass rose, and the expanded half screen shows 60 degrees of the compass rose, as you see in these 2 pictures. You can see the aeroplane symbol, local deviation scale, and the bar are at the bottom with the glide slope. Here or here. And they center full screen and center half screen modes show 360 degrees of the compass rose. Okay, so as the aircraft would turn, the compass rose would turn and indicate the heading, which is the top, that there at all times. The aircraft symbol, localizer, and deviation scale and the bar are in the center with the glide slope deviation on the right hand side. So this is the glide slope, we said, and this is the localizer. So this is the actual selected heading, or sorry, purple is what the FMS is telling me. This is what the selected from FMS. This is what I'm actually doing. Okay. And this is the purple one is the deviation bar. Okay. And it's actually the little white triangle is the aircraft. So it's telling me here, if you want to get on that purple line, you have to fly to the deviation bar. So if you turn your aircraft right, yeah, you'll see the compass rose turn the opposite direction, and suddenly the purple and the white lines should line up, and therefore the deviation bar should centralize as well, just like it would on an HSI, on a conventional mechanical instrument. Okay, guys, it's nothing new. It's on the NG. All of this is on the NG. It's just displayed on a bigger screen. Okay, so we got ILS information that can be displayed is the localized deviation in terms of dots of deviation. Yeah, how many dots you are off the center line, glide slope, how many dots you are off the center line, the glide slope. The source, system source annunciation, so where that information is coming from, which ground station, the station identity or frequency, the selected runway heading. Since we're in approach, we'd have to have a selected runway heading. We also have information up here like DME distance. These are all things that pilots need to, or the FMS uses to display or plan a route for the pilot to follow, or have displayed for the pilot if they are not flying on an autopilot and flying themselves. The engine indication display, it normally shows on the left or right inboard display unit. It's usually defaulted on the left-hand side. Okay, and it could, if, for example, for whatever reason, the screen was US, the pilot wanted, the captain of the flight wanted to use their ND, then their inboard screen for look at the weather or whatever. So the crew can move this display to the right-hand inboard display. What does it display? It displays the N1, which is basically the rotational speed at the front end of the engine, the exhaust gas temperature, the N2, the fuel flow, the oil pressure, the oil temperature, the oil quantity, the engine vibration, crew alert messages, okay, flaps data. So this here, if you can remember from the NG, this here is a mechanical indicator, normal mechanical instrument that is yay long and fitted on the instrument panel. This is now a picture, a display within the display unit, okay, on the EI display, together with the three indications for the flaps and slats under this instrument. All right, we also have the flaps data there and fuel quantity here, total air temperature up here, the thrust mode annunciation up here, and the selected air temperature. All right, so a little bit different. Now we said this is, as it stands, this is what the Boeing call a compact mode, because it has the primary engine indicating and the secondary indication all on one screen. You can select to separate it, to deselect it. You push the engine push button on the multifunction panel and put it from the normal display to the cluttered display if you want. Okay, in the decluttered mode, you'd have the N2, the fuel flow, the oil pressure, the oil temperature, the oil quantity, and the engine vibration on a separate screen, on a separate location to declutter this display. Usually, if I'm running an engine for testing purposes, I prefer this because everything's on one screen. I don't have to move my eyes onto different displays. I know what my vibration is here. I know what my oil pressure is here. I can shut the engine down if I need to because everything's in close vicinity of my eyeballs, of my line of vision. Okay. So systems display. Systems display shows when you push the MFD systems. So you can see up here, there's a push button here. And depending on your customer options, okay, the more money you pay, the more options you can have. Like, for example, hydraulic quantity and pressure is pretty much a standard, that one. But everything below that, like brake temperature is an option, the tire pressures is an option, and the flight control surface positions is an option, depending on how much money you want to pay Boeing to have it installed. If you don't have it installed, then the mechanic would check the brake temperature, the mechanic would check the tire pressures, and the pilot will have no luxury of looking at his flight control surface positions from the cockpit because he doesn't have that option. All right. Now, our membership is made up of two parts. There's a library resources, and there's a community to connect with myself and others. It's different from any other online training platform you might have been part of, as it has the human element with it. We don't just sell you a course and then send you on your way. We're there to support you and motivate you. So if you're stuck, there's real people there to reach out to. So here you'll find many resources organized in a way to save you time. Everything's mapped out from starting your career to getting your license to your first type rating to upskilling your qualifications. There's many non-mandatory courses, just like this one, that you can take that come with certificates so that you can be building your skill set ready to impress your next employer. The AME community, this is the other part of the membership, and this is where the magic happens. So inside the community, which you can see here, can be on your phone, you'll find forums where you can get help every single day. You don't have to go to Facebook anymore to look for support and spend hours scrolling and hoping to find the answers to your questions. You can now ask in a place where you can be sure to get the right information. If we don't know the answer to your question, somebody in the membership, or we will find somebody that does know the answer to the question. Everything you need is at your fingertips and easy to find in a user-friendly app that you can download. The community is a great place to make connections that are lasting and that will help you as you move along your journey. You can take part in as many or as little as you like. You decide. We do charge a fee for this, and you might be asking yourself why. Well, research shows that if something is free, you're less likely to use it. If you pay for something, it automatically creates accountability, makes you want to get your money's worth. Makes you want to get your money's worth and do the trainings and be active in the community. You may feel that $200 is a lot of money to pay in one chunk, but think of it not as a cost, but as an investment. Why not give yourself 12 months of support, resources, connections, trainings, and be part of a professional community, not just another Facebook group? We will be raising our prices next year as the amount of resources in the library grows. But if you join now, you will stay at the low rate for the whole time you remember. And there's more, the annual fee will keep going up. So it pays to do it sooner rather than later, because you will be on the starting rate, which is the one on the top left of this picture. here. Okay, so we will be raising the prices. There's trainings being added all the time. We got some exciting courses coming in 2025. Just as a small tip, we've got an EASA 145, FAA 135 compliant ATR Gen FAM course, which is coming up, which will be available in the library with certificate next year, which, if you remember, will be absolutely free. Okay, so and as time goes by, we intend to put more and more courses in all the time.